Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Farouk bin Ahmad Syamuddin and I am from BMMV S2-1. Today I will present my group assignment, computer simulation, which topic is simulation of structural, fluid flow and thermal of any mechanical equipment. This is my group member, Ahmad Zakwan, Daryl Isman, Wong Kempeng and Cik Malisa Maisara. The objective of this assignment, firstly, is to draw any mechanical equipment on any application using computer-aided design software. So my friend and I has been discussed and come out a result of a component which is been drawing by SolidWorks software. The second objective of the assignment is to analyze the component using FEA Finite Element Analysis or CFD Computational Fluid Dynamics or BOT software. So our group has been discussed and we would like to use finite element analysis for our drawing. Okay, next let's go to the flow process. In this assignment, we have 4 flow process. The first one will be the import from CAD, which means we import the design to the Altair Aspire. The second one will be the pre-processing. In this section, the geometry FEM analysis were done. Number 3, solving. The solving problem will be made by the Altair solver. And the last one will be the post-processing. This is where our result can be seen and will be discussed in our group. Why we choose FEA? Firstly, we choose FEA because in this assignment, we need to experiment our design strength, heat transfer capability and fluid flow, which is stated in our topic. And the second one will be to predict the performance and behavior of the design and calculate self-free margin with the identify the weakness of the design. That's all from me. Thank you. Next, I will pass to my next group member.
Hi, I'm Marisa. So today I would like to explain about procedure. First of all, we need to sketch the part using SolidWorks and the chosen part is nozzle. Second, we have to change default unit system in customized unit. Third, we have to import the part in Inspire software. Fourth, the material is assigned. In this simulation, we use 2 types of material. The first one is iron, alloy cast, and the second one is steel, AISI 304. Next, the load is applied with a value of force. The value of force used in this simulation is 500 and 1000 Newton. Next, analysis for buckling is started. 7. The value obtained in Analysis Explorer being discussed. There are 3 values being discussed in this simulation. First is displacement, second is factor of safety, and the last one is one missile stress. That's all from me.
Thank you for the procedure explanation, Malisa. My name is Wong Kempeng from BMMB S2-1. I'll be presenting the results of this simulation model using finite element analysis, which is FEA. In this experiment, the results are differentiated by 2 distinct criteria. For the simulation model of a nozzle, there are force differences of 500 Newton and 1000 Newton, as well as material differences of iron under alloy cast and steel AISI 304. Both of which are often used in the production of nozzles. As seen on the slide, results are shown using 3 distinct methods. For the displacement, a student can only distinguish the outcome using a value list, since various materials have a negligible effect and the length of force applied to the nozzle is the most important element in determining displacement. For the factor of safety, the student is able to distinguish between the outcome and the image and recognize that steel AISI 304 is a higher quality than iron under alloy cast, as various materials will only have a significant impact on the model. For the von Mises stress, a student can only distinguish the result using the value list, since various material has little effect on the von Mises stress and the nozzle uniaxial tensile stress is the most insignificant variable. So, since the force is applied at the same distance from the support, the displacement for 1000 Newton will be less than 500 Newton. The safety factors will be much lower than 500 Newton variant due to the employment of a larger force with the same nozzle dimensions and material used. The von Mises stress will be greater than the 500 Newtons model because the greater force input results in a greater stress on the model. So I will now pass the presentation to Daryl for the discussion
Hello,
portion.
my name
Thank
is
you.
Daryl Esman, and now I'm going to explain the discussion of this experiment. So there are a few types of FEA. The first one is structural static analysis. This method of FEA examines a proportionally sized model. Any structure that is considered small scale will be able to manage the same interaction with a full-size structure and also generate the same outcome. Second one is thermal engineering analysis. These tests explore variation of temperature and how it affects the design structure. The third one is model analysis. So every object have a frequency. This FEA enable user to check the vibration during design and deliver a sturdy final product. And lastly is engineering seismic calculation. This enable designer to understand the product response to different ground frequency and vibration, ensuring a solid formation for final construction. And now I'm gonna explain how FEA works. So there are three important steps during this FEA process, which is the pre-process, process, and post-process. So during pre-process, the user select the analysis type and element type. Then next, they specify the material attributes and make nodes. So connectivity at nodes build the component and apply boundary condition and loads. Second one is process. So this stage, the procedure is carried out by the computer. The computer will solve the boundary value issue and then display the result to the user at this stage. And the last one is post-process. So during post-process stage, the user are able to examine the obtained findings and make comment on variable such as the displacement, temperature, time, stress, strain, and frequency. So that's all from me. Thank you.
Hello, my name is Akmal Zakwan. In conclusion, we can observe that steel is better than alloy cast for structural members. The outcome of the analysis validated it. Aside from that, this test revealed that the material of model or mechanical component was the primary cause and factor for displacement value, bond mistress, yield percentage, and safety factor. However, we cannot deny that the design also impact the outcome. Finally, we can show comprehension of simulation result of finite element analysis utilizing the INSPIRE program based on mechanical engineering. That's all from me. Thank you. That's all from us. Thank you.